Have you ever wondered why some things float while others sink? Hey, what's been on your mind?
Do you ever wonder why does a massive ship float while a tiny coin sinks?
What's been bothering you?
Are you okay?
Have you ever wondered how do submarines control when to sink or float?
Hey guys! Hey! Have you ever wondered why hot air makes balloons rise?
Hey guys, have you seen this video?
To answer these questions, join us as we learn the concepts behind these phenomena of buoyancy.
Buoyancy. Buoyancy is simply the upward force exerted by a fluid. It could be a gas or it could be a liquid. Those are both fluid and that opposes the weight of an object that is partially or fully submerged in that fluid.
So, have you ever wondered how does a massive ship float like this? But a tiny coin sinks.
According to Archimedes principle, any object submerged in a fluid experiences upward buoyant force equal to the weight of the fluid displaced by the object.
Now, to demonstrate the Archimedes principle, we need various items, like a container full of water, some plastic toys, some coins, and a key. Now, the plastic toy floats because its density is less than the water, thus floating. And now, because the density of the keys and the coins are higher, gravity pulls them down and sinks to the bottom of the water.
This explains why a massive ship floats but a tiny coin sinks. A ship displaces a large volume of water, creating enough buoyant force to balance its weight. A coin with a small volume and high density displaces little water, so the buoyant force is too weak to keep it afloat.
How do submarines control when to sink or float?
Pascal's law states that when pressure is applied to a confined fluid, the pressure is transmitted uniformly in all directions.
To perform the Cartesian diver experiment, we need a small diver. For example, a dropper or a pen cap with the clay attached to it. But in this video, we have a dropper with some paper clips attached to it. Then, put the diver inside the bottle with the confined fluid. As I squeeze the bottle, we can observe that the diver sinks. And as I release, we can observe that the diver rises. Squeezing the bottle increases the pressure on the water, compressing the air into the diver. This increases the diver's density, allowing it to sink. Releasing pressure on the diver decreases its density, allowing it to float.
This explains how submarine control sinking and floating. Submarines use ballast tanks to adjust buoyancy. Filling tanks with water increases their density, causing them to sink. Replacing water with air decreases their density, allowing them to float.
Why does hot air make balloons rise?
Density is the mass per unit volume. It helps to determine whether an object will float or sink. Objects that are less dense than the fluid or air float, while denser objects sink.
Use a sky lantern for this demonstration.
Light the lantern and observe as it rises. When air inside the lantern is heated, it expands, reducing its density compared to the cooler, denser air around it. The less dense air inside creates an upward buoyant force, lifting the lantern.
This explains why hot air makes balloons rise. Heated air inside the balloon expands, becoming less dense than the surrounding air. The difference in density creates an upward buoyant force, lifting the balloon.
As mentioned earlier, the buoyant force is the upward force exerted by a fluid on an object submerged in it, which opposes the weight of the object. This force is essential to understanding why objects float or sink in liquids and gases. The magnitude of the buoyant force is determined by the Archimedes principle, which states that the buoyant force on an object is equal to the weight of the fluid displaced by the object. By applying this principle, along with the object's volume and the density of the fluid, we can solve the buoyant force and predict the behavior of objects in fluid. Here's one of the example. A small sailboat displaces 30 cubic meters of seawater with a density of 1026 kg per cubic meter. Determine the buoyant force on the sailboat. Step 1. Identify the density of the fluid. Step 2. Determine the volume of fluid being displaced by the object. Step 3. Plug the answer from steps 1 and 2 into the equation. Buoyant force is equal to the density of the fluid times the volume of the object times gravity. So it will be buoyant force equals 1026 times 30 times 9.8. So the answer is 301,644 Newton. The buoyant force of the object is 301,644 Newton.
Oh, so that's how it works.
Wait, where's Luna? Luna?
Luna?
Luna?
Luna! Luna!
Luna!